welcome back to Advent of Code, running on SerenityOS using the jakt programming language. We're on day 21 now, so we can go new day 21. And that should get us some things. This example is kind of long, but not numbers. I was thinking it's a number context, but it's not. Some are going to be numbers, like that one, dbq, dbt, dbt3, lfq4, 5, lj, jn, 2, stn, zn, dbpl. Good luck checking my typing, I guess. gbd, ljgn, btd, dq, yep, that's the one. zn, dt, zzz, hmdt, 32. That might have errors, but that's alright. So I thought, while I was talking about the keyboard, what we could do, maybe just use this. Can we? Yeah. So the layout I'm using on my keyboard at the moment is not the QWERTY. So like if I type QWERTY, that's what I get. It's not QWERTY. We need to actually search with something. We'll try Google today. Yeah, that's the one. So this is what my layout actually looks like, which might explain any typos you might see if I ever do them. But yeah, small sidetrack. Right, our example output is part 1, part 2. So what this is basically a mapping of like a name. So I think this is like, yeah, the monkey's name, and then the right hand side is either going to be a number, like this 5 or 2 or 3, blah, or it can be a simple equation. So I think it only has plus, minus, times, and divide defined, and spells it out here as well. And the variables here are just other monkey names. So here's PPPY, W, sorry. And I think the output is we just want to know what, the number this monkey called root is called. So it's kind of like a tree structure, I guess, but it might not actually depend on everything. There might be independent tree type structures, but root will be the root of a certain tree, and so we just need to kind of parse this and then work out what this will evaluate into. So I reckon we could go and do it. Will Hack Studio crash? It will not. Right, so how I'm going to do this is we're going to have a monkeys, I guess, and it's going to be a dictionary of string to, maybe I'll call it like equation, and we're going to have a new dictionary for that. So for this equation, we could try like a fancy enum equation, which here like you can have like global variables, some beeping. So we can have something like this, but we can also have like a equation, equation, and I think that will work. We'll try to do tests of 21, maybe just an example for now. We have this on always on top. We don't want it. Use boxed enum things. I think that's potentially the first time the compiler's actually been helpful, rather than just spit out like a million errors that you're like, what do you want me to do? But yeah, this looks good. Alright, so it just prints out the input, but it compiles with this. So, and I think we can probably even have like we can have a split on colon, I guess. And there's like annoyingly a space, I guess. But that's right, we can then go, we can go monkeys dot set split 0, and we can set it to equation pass, I guess, of split 1, and we can just define that pass. So I think you can just do like functions inside of the enum, which is pretty crazy. Right, so what is this going to take? It's going to take anonymous. I kind of want to get back there. It was like scrolled off by 1, and sometimes does that. And here we're going to take a string, and we're going to pass back an equation. And for now we can panic. Maybe we can just abort, which will be kind of annoying. But yeah, it should compile and just abort, which will go, abort. But it shows that we are getting here, I guess. It's useful to know that your compiler, your code is valid at certain points. So, this thing, I want to go let num equal to s.to int without the bang, and then if num dot has value, in fact, a value. Maybe we can do that as a question mark. Yeah, I think that will be valid. We can maybe put line whatever the value is. We'll just do that. And if it does not have a value, we'll do something else. Except we need to return the equation. So I guess we can just return equation value, and that might just work. And here we will do something else. But maybe we could probably go. No, I kind of just want to value is 0 for now. Right, so we can't do that. Constant. I think. Do something like that. Right, so to int as AI64 question mark. Seems kind of wrong, but that's right. Right, paths does need a throw, that's fine. Throws. So we can't do that, but we probably can do constant. And so now I'm hoping it will print out, well, it won't print out anything because we can't do that. But what we can do is, I mean, could potentially just do that. No, I kind of want it to be i64 because I can handle it as dang i64, but I think I might, yeah, we need to say that value is going to be that. It still doesn't like that. Is within range. Oh, we need to like, it's just going to do that because otherwise you kind of like need to dereference it, then wrap it back up in some value, I guess. Yeah, cool. So they'll do the trick. And then it will print out the numbers 5, 2, 3, 4, 5, 2, 4, and 32. Cool. So here, I probably want another split. S.2 string, not S.2 string, S.split on maybe space, and then maybe we can just print line and print out that split so we can see what it looks like. And I'm hoping that there's no trailing space and there's like just a nice handy three things in the array. Yep, so there's always just 3 things in the array, and the second one is going to be that. So from here we can yeah, I think it's not actually going to be a boxed. It's just going to be, yeah, it's not going to be recursive. It's just going to, and then here we can return match on split 1, and in here we can have plus. And this can be equation add, and A is split 0 and B is split 1, like that. Yeah, and here we can probably just copy that whole thing, except like only up to there, so maybe just do that. And do that a few times, and then here we can, where's that one? No. That one again, and here we can minus and multiply, and here we can have divide. And here we can probably go else unreachable. Maybe we have to go panic unreachable equation pass. That is probably alright. And then here we have returned a thing. Potentially having this a bit wider might be nicer, showing all of that. Yeah. So here we can probably not have that, and it might not even compile. Yeah, it doesn't. We don't know about panic, but that might remove a few things. is like all right. Can we go as being equation and like it'll just never go, and that is because we also need, yeah, I thought that might, we just need to copy that. Gosh, need to copy just that, because when we add a new line it will take us out. Multiply, that wasn't the key I wanted, but that's right, divide, and this will be a string, yeah. Right, so we define all those. Right, so I think we need this to maybe be set to none. Yeah, that's what we need. So all the others default to none. Right, we can't cast. Yeah, that is. What we could do is do this and use the equation. Unknown maybe, yeah. And here we can just have like an unknown. Doesn't like that. We abort for some reason. Out of memory. Free minus H. Do we not have that? I did recently, yeah, I've got 5 gigs and I'm not using that much of it. Out of memory seems odd. That gives a different error, and so we need like that line for the type checker, but then we need that to be wrapped up, because yeah. Right, so we have parsed everything, I guess that means. And here we just want to like print line part 1 is going to be solve of monkey's root. And maybe we can just pass in monkeys as well. Function solve, or like maybe, yeah, maybe we want something like this and monkeys, and then we have a function here, function solve, which will take this, and it will also take out monkeys, which will be a string to equation, like that, and it will return us I-64, I guess, 932. Maybe an optional, because it might not solve it, but then here we'll just have to do that. Yeah. Yeah, right. So I think we can have a guard on dot value dot has value. Well, really it's not a guard. We can just go, if we had a value, we can just return already parsed the whole thing. And I think I might want to like make things mutable like that, but then we might also make this mutable, but we might also not. Right. And here we can, so now we kind of have a return a match on this, I guess, and if it is, and I think we can do stuff like this. We can return a.solve. No, we need to monkeys a.solve plus monkeys b.solve, and this is quite long. Maybe we'll just call this D for dictionary, and then that can just be a bit smaller. And we can have that a few times, and we can have an else, and here we can probably just maybe even just return none there, because we do have an optional return, and we could potentially just get rid of that, and then here if it is constant, wow, we want this to let ret equals that, and then return ret. And why I want it to be mutable is I kind of want to go this dot value equals ret, because after we solve it, we solve it, I guess. Minus subtract and divide, and so this will just change this operator, and that will be that one, and that will be that one. You run into a risk that b.solve is 0, but then that will just be a divide by 0, I guess. And that can just happen. Right, so we can't do that. Right, so maybe this D can be anonymous because it's not a great name to expose. We don't have subtract, and for some reason I put subtract instead of multiply. Right, so this, we do need this to be mutable, and it reckons this is still mutable. Alright, all those solves need a D to get passed through. And yeah, now it's like, you can't do that. This dot value, why is it immutable? I say I want it to. I guess if you don't do it, it won't cache it, but that's probably alright. It might not be, because things might depend on a lot of different things. Right, so we have I think I just want that to be that, and and do something solve. And this probably just needs a yielding of 0 out of 32. Just so the type check is happy. And is C++ happy? It is not. So that's after it's 21. Yeah, so that's like after we're getting something. No idea where it would be. Like it's not very like handy that. So it's when it's trying to get an end pointer. It's when it's trying to unwrap an optional. So I wonder. I32. If we do something like that, takes out that one position, that we right, so we still get a thing there. Where else did we do a bang? We only did a bang there. I guess this also doesn't need to be mutable, and I need to get out of this because it's complaining. Yeah, why? I guess in previous times where I've done this, I do little things like print line here, and down here, print line here too. And we basically see whether I got that out of memory again. The out of memory is like a weird one. And so we get here, here too, but we don't get 3 other here twos. So I kind of want to see what that ret looks like. And maybe this can be what this looks like, just so we can see what things look like. 'Cause sometimes knowing what things look like is good. Right, so the B is not what it should be. This should be 2, 2, 2, and 2. And now it might just not crash, but it might print out lots of hairs. Yeah, so it printed out lots of hairs, but it passed, I guess is the thing, but we never print out this, which I'd assumed that would get printed out. I think it's because we've just got the right answer. So without the printing of here, yeah, we just have the right answer. So if we run it for the real input, yeah, so we do need it to be I64s. And I guess because how I was wanting to do it, it can't be done. What we could do is have that, and here we go, value is value bang is bang I64, and here we are going to return a all the time, and here we will get passed in the value and we'll just return it and it won't be a bang. And here we probably don't need to type it, and the rest look good. So if we do that, it should still pass for the example, and hopefully the actual input doesn't overflow. It might still, if it does, don't know. It gives an answer, so that's good. So what we can do is 157714751182692. Hopefully the rest of that is good, and yep, that is the right answer. It's a big number. Then outputs day 21 dot output, and we can paste that in there and maybe have a look to see what we did. Yep, that looks all good. And we can go to day 21 part 1. And what have we done? I think I kind of want to just go on to part 2 and see how it goes, because it feels like it's winding up for the advent and it's getting a bit easier. Oh yeah, we're doing like weird monkey elephant. The monkeys talk to the elephants and the elephants talk to us, and yeah, it's nuts. Right, so root should actually be like tested that they are the same, I guess, and then return true or false. Right, so we also had another one. Oh, that's human. I like it. Whew, I got it. Right, so this human one we need to work out. Yeah, I kind of want to cache it so I can see what everything looks like. Right, maybe this isn't as straightforward as I thought, because yeah, you basically need to get root down to a dependency of just human, I guess, and then once you have that, and like we can use some transitive properties, I guess. So yeah, this PGDQ, wherever that is, it's used here. No, because we're like in the middle. So yes. Just thinking how I can rearrange things. So the issue is we basically got something like root equals a plus b, but for the second half it's actually and like this a can be a bunch of stuff, so it might be like a plus b minus c divided by d, maybe all of that stuff with like the right brackets and everything, and then this b side, it could be something like e minus f times g, maybe divide g and then times by h, and maybe with brackets like that. And what we want to do is make that h equals whatever everything is. So like looking at this equation, that's possible to do. You would have root minus this thing here, we have this for the first half, but then it really becomes we're trying to make sure that this is correct, and then you'll be then solving for h equals this, and so that would be in this particular example it will be all of that divided by all of this, except without one bracket there, and then that would get you the h. So you kind of need to find where the h is used in that kind of tree graph from root, and then you want to assign both sides to be equal, and then you want to like kind of solve the equation in terms of h, which I think would require a bit of refactoring of this like equation model. But it is kind of in a good way, like I guess we can call solve on each of the parts, so we kind of need to get the second, so maybe we can let root equal monkeys root, and maybe this can just be called root, and maybe this can happen on that line. Otherwise we have I wonder if we can, is root always a plus type thing, like our input, that's right, we can't search, it's just there, that's cool. Right, so it is a plus in there, so like root might just be equals, and it might not be. I kind of want to make it able to go for both. So I guess we could do something like this, root v equals match on root, and if it is add a b, we can just return a b, and we can also probably have an else, and just do this kind of thing again, tab that one out, and untab that, and what are we yielding? We are yielding a two-string. Right, so now we've got kind of root A and root B, and from there we can kind of need to remove human, and have the solve fail if it doesn't exist. Which, yeah, I guess we would have to change this a little. I wonder if I can have a little helper function here, function solve, and we're going to take I'm trying to think. because what I have to do is basically something like this and do that, and let RA. We could probably do this in yeah. Do something like this, and db dot solve of the dictionary, and here like if if not d dot contains a in fact maybe we'll do this as a guard d dot contains a and d dot contains b, otherwise we will yield none. This value here we probably need to go some value, and here we probably also need another guard that RA dot has a value and RB dot has value, otherwise we would yield none, and otherwise we will just yield RA bang plus RB bang. And so the ad got a bit more, but like this stuff is very similar. So I think what I want is to have a solve on this, and we'll take in our D. In fact, we could probably not have an anon for this. We would take in our D, we would give in our A, which is a string, and a B, which is a string, and we kind of want to return two values that are optional integers. So that's basically going to be the return code of this, and here we can kind of just get that and have like this. Return RA bang RB bang, and I think we don't want the optionals there, we want the optionals there, and it's kind of showing that we have basically got it, and then we can tup can be solved with the A and B, and if tup dot has a value, we would like, yeah, I guess we can actually go yield on match of this thing here. Is that how we do that? No, we don't do that there. And here we can have some RA and RB in a tuple, like that, and we can just return RA plus RB, and if it is none, then we can return none. And then we can kind of get rid of a bunch more stuff. And here we can basically do this and then change that to be minus, and then this can be changed that to be multiply, and then this we can change that to be that. And I think in this point we can go if b equals 0, maybe we can do a guard rb is not equal to 0, otherwise we can yield none. Otherwise we yield that value, except it's divide now. So the divide had an extra check, I guess. And that means we can probably just return none there, and this rep is going to be all good. So maybe that solve works. I wonder if that, I don't think I had done it. Right, we'll have to fix some compilation errors. Yeah, so I guess this is this going to be a tuple, and that's going to be t.0 plus t.1, and maybe I'll copy paste that there and make that minus, and this, and gosh, that's not what I wanted there, but I think if we select a bunch we can do that, and here we can have t and t.1 and t.0 divided by t.1. Is it not a tuple? I thought it was a tuple. This isn't as going as how I thought it would. Right, so we can't yield in there. And t is not found, but like t is right there. Right, I guess maybe we can have I wonder if that will do the trick. And maybe we can just do else there, and maybe put it, gosh, I like that, and then do some bangs on that, because then its types might be a bit better. Right, that's not what I wanted. I guess I want that whole thing to go there, and then that can be minus that can be times and this can be divided, and in this case we would if t.1 t bang.1 equals 0, yield none, yield that thing. Right, I think think that did get a bunch. Right, so we can't do that, but I think we can just return that, and we can probably return this. Yep, that's all better. Right, I reckon we got void from all of that. Is it because we're like in a block? Can we just return none then? Yeah, no, it just reckons that we never actually yield the return that we want, just because of the way we did it. Right, that looks like it wasn't expected. Yeah, so I guess this matches. If match if t dot has a value, gosh, I'm changing what I want to do many times now. Else return none, like that. So I guess I'd want something like that, and minus and multiply, and this whole thing, wasn't it? And t star dot 1 not equal to 0, and that is and. Makes for a slightly better if statement there. Right, that looks like it's compiling again. It's always a good when it compiles. We can't do that for some reason. I kind of want to look at this file actually. Right, 39, then build day 39, let's see, thought that exists, 21, line 31, 39, right, so what are we doing here? I think I need to look at our yakts, and we need to do some debug. Yeah, minus P minus capital S. Well, we don't really need the capital S. Yeah, minus D minus P. Minus D minus P day 21.yakt, and that should hopefully fail in a similar place, but now the file will be much bigger, and it will say like kind of what we are doing. 102. That's kind of annoying because case 1 yeah, one of these, so that was 207. Not like 102 and 107. probably this, and so I reckon line 42 of this, line 42 is that. And it doesn't like that. It's too much nesting. And I was trying to do this because I wanted to basically in here we would get our two roots and solve both of them. One of them would be none. And then we could kind of simplify the thing. So here we would have like a value, so like 39 equals none, which means that we need to then kind of go through into that node, the one that couldn't be solved, and depending on what function this was, we need to actually no, it's just an equal. Yeah, so depending on what function that is, so say if it's like a plus b, it might be like a plus g minus h, and then we can see there we have the h, which will be none, and then we could just subtract f from 39 and we can solve for f, and we can just do that, and we build up that way until we're basically left with whatever h should be. I think that's kind of how I envisioned it, but this is just not going well really. I guess we could yeah, what I could do is if this is constant value, we can probably just return some value just there, and then we can go we can get our ABs out of match this, and here we're going to have I didn't do that, add a B, and we will map this to solve D, A, B, which will get all the intermediate stuff, and here, no, not that, get back to there and go there and there, minus and multiply and divide, and the else can probably just be none, I guess. Maybe the no. Can be that. Yeah, and here we can then, based on that, we know our AB. Well, actually no, we know our tuple, so we can just call it tuple, and then here if t dot, well we can actually guard t dot has the value, otherwise we can just return none at this point here. And then we can probably just return a match on this, and we can have it add. I wonder if we actually need the names on it, and there's no like easy way to do it except maybe no, because yeah, we'll just see how we do it. Return match on this, and here we're going to have an add, and it is just going to be tbang dot 1 plus tbang dot 2 minus is going to be the same but with minus. That wasn't what I wanted. That is what I wanted, but with that, and maybe I want to do that, and here we can do the same thing there. My monitor's doing some clicking. Right. Multiply and divide, and so that can be that. Maybe in divide we will first check if t bang dot 2 equals 0, then we can return none. Otherwise, we yield whatever this thing is. Yeah. And here we can probably just return that. And oh yeah, that was quite a large thing. Alright, so now we basically solve the two halves, and then we can see whether we have a solution to the two halves. So we're in there, but if we go back to this, right, we still can't do that. Yep. It's only a few places. We want 1 and 0 and 1, not 1 and 2. But the type check are new. The type check are new. And now we've got some compiling code. It's always good when your code compiles. It doesn't. It's giving that same error that it was before, where yeah, I wonder if we get rid of these ones, will it like complain? Yeah, it won't let me do that. Yeah. Oh, it's probably this. It's probably this. It's probably this. We'll just get rid of that for now. It was probably that all along, but the code looks kind of nice. Yeah, so it still works as expected. What this kind of lets me do is we could probably also like monkeys dot delete. Yeah, I think it's delete and human, and here we can probably like give it the same thing, and we should get none now. Example, and alright, we can go into, not there, alright, we can go, yeah, we can go into there, and this is a dictionary. Remove, remove. Right, so now if we run this, it should find none for the part 2, which is good, because it means that we're like making it fail. I think that's because of that. Right, so here I think I want to make another function solve2, and this is going to take a, we can potentially actually just do it here, function solve2, and it is going to take the same thing as solve pretty much, this and this, and it's going to return us something. And for now it can just return none. And yeah, when we do this solve, it's going to return us none, but when it's none, yeah, so that will be solved too, I guess. When it's none, we want it to work out the two sides and then like do the thing. Yeah. So I guess it's going to have a similar thing. Yeah, like what we want to do is, we kind of had it before, so we want to do a match on this, and if it is add, we want to do a thing. If it's a minus, we want to do a thing. If it's multiply, we want to do a thing, and if it's divide, we want to do a thing. And if it's not any of those, we don't really care. So we can probably do this code here, but isn't solve do. So this could be a constant, but if fruit's a constant, then like the whole thing kind of breaks. So if we have, we kind of want to get the two parts. So we could probably let this like do a similar thing that we, in fact, like we could probably just copy that. Like that is roughly what we want to do. We want to, that's just solving both halves, and it returns none if it can't solve either of the halves, so that's not quite what we want. We want to return both halves even if yeah. So I think that is going to be we're going to have that, and so in this solve2 case, I think like this can probably just be in that, and that can be none. And here we can we can just let this be whatever it was returning, and that can just return, because that's kind of what we want, A, B, like that, and then this can just be the rest of what it does. So just solve will do that, but solve2 will kind of give us the intermediate results, or nothing if it doesn't exist. Except we kind of want to like mute RA equals and it's going to be -64, and that can be none, and if we contain it, then A can be DA dot solve D like that, and maybe if it contains B, then we can do the same for B, B and B, and maybe because it's typed like that, we can just go like that and do that, and then here we can just return RB, and that way if one side is not in the dictionary, which it won't if it's human, it will return none just on that side. And so here we should get a T, I guess. So we can probably print line T equals this, and it should give us a thing, except this we need to yield 0, 0, I guess, because solve2 will we can just return none, none. Right, so it compiles, and what does it get up to next after that compilation? So we get 1T. Yeah, so we get the 150, which is what the other one does, and because A was bad, what this kind of means is we want to recurse into that more. Yeah, so if T dot 0, we kind of, no, this is cool. If T dot 0 is none, we are doing a thing which is what the case is now, but we need to rearrange it based on that. Rearrange. Now we kind of want to recurse into, we want to get D of A, which we don't have kind of stored with us. So I guess we kind of want to bring it with us. These A and B's. The the solve 2 just takes A, B. I guess we could probably just return a string and a string. And we can just return whatever we return. It's kind of like the functional thing to do. But on this solve we don't really care, but we just need it from there. And then our tuple will have, like we can let A equals t dot 2 and let B equal t dot 3. And because t dot 1 is none, that means we need to recurse to d of A solve 2 of just d. And in there we should get two separate things. Else if t dot 1 is none, we want to do the same but for d of b. And then we want to like, depending on what operation this is. No, it's really depending on what operation A is. So if A is like plus, then you want to subtract B off. But if A is a minus, then you want to add it on, multiply. You basically want to do the opposite of everything there. And because because A failed, it basically means it's none, which means the solve 2 failed, which I think it will call that, which will just kind of recurse into this. And so if it's a constant, it will, if it's a constant, it will just return it there. Yeah, so that looks good. What's time? That's good. So we can probably do a match on d of A. Now there is a chance that A will just be human, and if A is human, then we like kind of maybe I'll do a fix me. Fix me if A equals human, do something. Because we might need a return from this. So I guess if A is human, then we can say the answer is just whatever B is. And I think I want to do these outside, and maybe let R, B, A, and B just equal to T. In fact, we could probably even do it up there. And here we probably need to do a couple of extra nuns and none. And then we're not like doing that R, B, and we don't have to like worry about all of that. So I think like I haven't got an answer, but I am getting a bit tired. We don't have a T, that's alright. We can probably just go R, B, A, B, like so, and it will just work. We're not allowed we not dot has value, dot has value, and if not, this dot value, that is what we want. That now compiles. Maybe I could go. I hate it. Cause some more errors. Got a courier thing coming. Right, we are not allowed to have that going. I wonder why. It's annoying because you can't really see where it is. I guess we can do this command and then search for just optional with no bracket. Yep. Yeah, like 88. It's doing like a lot of things. Yeah, this optional none seems suspect, I guess, because we're maybe just always returning none there. It's not really like in a working state. I wonder if like that's broken. No, that's not the one that's broken. And we're calling solve2 for everything, and solve2 just returns the A and B that we can't just pass in. Yep. Is it not liking this? We can just do that maybe. Yeah, so this optional, where does it reckon it comes from my file? Not there, not there. This one, 88. And then build day 21 CPP 88. And of course it's going to be the right thing. 88, and we jakt bar 4. Right, so in here what do we have? We have an optional of I64, then we have an optional none, because yeah, we're casting a none to optional, and then we've got another optional 64 there. And here, I guess it doesn't know what it's meant to be returning. Because like, is it this? We can't return none, we gotta do that. Right, that should be this. Right. So yeah, I guess what happens if we just go d a dot solve to of d, and maybe like just return that, I guess. We're always just going to return the right one, and here we can do that and maybe replace it with, oh yeah, that wasn't what I wanted to do. I wanted to copy that and then do that and then there, and maybe before we recurse we print out what we currently have. So it should probably crash because it recurses infinitely. Well, it potentially doesn't actually. It did. So what if we just go build day 21? Yeah, here we get none and we get our, in this case A is the human, and so here we need to do something different. So here if A equals human, then do a thing, return none for now, I guess, and if maybe there, if B equals human, then we can also return none. But I think we just want to return the opposite number, if that kind of makes sense. So we'll do A there and B there, and if they are none, then that's alright. But yeah, we basically want to drill down to the point that we're looking at the human, and then we know, hey, that's that. But then we, as we kind of build back up, we want to rearrange the statements. So here it just says 3 because that's what dvpt was, but because dvpt was done in, yeah, let's scroll up. So yeah, we're basically looking at this. Double click there and it highlights there. Right, so we're looking at this, and we could potentially put that here. Maybe we can always on top of this again, just momentarily, and here we can say ptd dq equals hum minus dvpt, and that is being used by lgbvd. vd is lvn minus times pt dq, dq. Cool. And so here we actually got a value for the LJ thing, so we know that's 2, and we know that dvbt is 3, just because that's how it was solved. And here we're wanting to get that human variable. So this is going to maybe that is like that. So we're going to end up with an equation that looks like 2 times human minus 3, and like kind of put that in there. And then we can probably go hum minus 3 equals LGVD divided by 2. And I think we kind of just want to build it up like that, equals LGVD divided by 2 plus 3. And it's kind of like reversing the operations on each one as you go. Except like that's not really something that we know, but eventually we should get to a point where it's root. Well, it's not actually root, it'll be whichever one is not root. Like in this case here, it would be singe. So we'll probably get something in terms of that. Yeah, I think I want to leave this now, but we've got kind of fix me do actual what do you call it when you're like solving of equation, and we can probably get that off always on top, and that's probably also there. Yeah. And we like just bubble that 3 all the way to the top. But yeah, so I think that is enough for today. So I got like, yeah, I got part 1 at the start, didn't I? But part 2 needs a bit more. Status get diff. What do we do? So we kind of just boilerplate for adding the 2. Actually, we need to vim output stay 21 example, and this we want to get whatever the data was meant to be 301. Part 2 is 301, just so when we do this it'll show what it's meant to be. We're close, just off by 100 or so. But yeah, we can commit that up day 21, part 2 prep, and we can really push both of those up, and I think that is good for